Hi everyone. Some of you probably know me. My name is Milos. I passed, I don't know, 10 or 15 years I've been working as a system administrator mostly. But recently, I have a degree in computer science, so I do lots of programming, but somehow I just found my way, found my way to operations and development. So recently I've been spending lots of time in Go in Rust. Coolest technologies. All probably I would say hottest, fresh from the oven. And I also have a lot of containers. So there's blogging. I blog very rarely. So, but there, you might find some interesting over there. Cool. Let's talk about Linux containers. I'm not exactly sure why this talk was named Rocket versus Docker. Because last time I spoke with Mark, we had each other about Rocket and Docker and about differences and that kind of stuff. But then I thought about it like more and more. More time I spend in RC channels and talking to people private messaging me, and all these things. I realized like comparing something like Rocket to Docker is at this stage it's just like ridiculous because Rocket as it stands now is just a pure prototype. It was developed by CoreOS, but it's just a pure prototype. Like there's lots of development happening, lots of active development happening, lots of PR being raised open, and obviously because it's prototype, lots of things are breaking, and lots of things are being designed and all this stuff. So, but I did spend a lot of time actually recently hacking on Docker. But let's go back to Linux containers. So these are probably the most widely used Linux containers, the most widely deployed Linux containers around the world. So LXC, that was developed by Ubuntu, that was adopted by companies like Heroku and many other early platform as a service providers who basically championed using Linux containers. Then a lead container came out from Docker, who originally based their Docker engine on LXC, but then they decided to build their own Docker engine because they wanted to be more agile. And also they needed some functionality which wasn't provided by LXC and which would be very hard for them to actually convince Ubuntu guys to implement the functionality. And then we have systemd Ansible, which not a lot of people probably know about, but it was introduced last year on Linux Common Europe by the one and only Leonard. And it was basically developed for systemd developers, for testing and debugging systemd. As you can see, like, you probably understand that developing something like init system for operating system is no fun. So you can't be crushing bare metal operational machines all the time around. So they happened something around systemd, obviously, and systemd Ansible was born. And that is actually systemd Ansible is at the core of Rocket at the moment. The reason behind it is probably most of you probably know that CoreOS is using systemd as their init system, and this was the easiest option to go with at the moment. But it doesn't mean it's going to stay there. So it's probably going to be changed at some point. But where it stands now in the prototype, we're using systemd for responding containers. And there's probably lots of other container solutions which we probably never even heard of. At least I know at least like 2, maybe 3 people who are working on their own, and which are actually being deployed in the development environments. Cool. So one of the most deployed ones is Docker. There's been like lots of talks. Who here is running Docker in production? Who is that? Oh, cool. We have one person. Awesome. 2. Cool. So yeah, it's just a quick summary. Probably everybody knows a lot about Docker. So it basically it has 2 main components, which is actually one. It's this massive, chunky, statically compiled binary, which is run as a daemon on the server, and you have exactly the same binary, which is used as a client to interact with daemon and do other things like interact with Docker Hub and build the containers and all this stuff. And there's also other things which Docker provides, and you're probably familiar with, like overlay FS and all these things. And there is like lots of new things are happening in Docker, such as clustering and Docker host management across various cloud providers. And plugin design, which we don't really know what state it is in, but lots of people are talking about it, and it's just being a thing at the moment, just happening. There is nothing that's being officially used. Cool. CoreOS. Let's talk about Rocket. If you, yeah, I found this on Twitter and I felt like, wow, this is very good. Cool. So CoreOS Rocket. I don't know how many of you actually read the blog post or the announcement of Rocket, but essentially what CoreOS guys are attempting to do with the Rocket initiative, should I call it, because at the moment we can't really call it more than that. Maybe a little more. What they're trying to do is like they're trying to standardize application containers. This is something what really, in my opinion, should be done by Docker. It would be hugely beneficial for the ecosystem and for the whole container environment and all this stuff. But as it always happens, like with cloud adoption, with the tool adoption, or with the software adoption, it always happens like, cool, we need to monetize stuff. So we need to somehow like roll these features to various places. There is nothing wrong with that. You want to obviously you spend a lot of time working on the thing, so you want to make some money. But in my opinion, there was a huge missed opportunity from Docker side to create actually some kind of like container standard. And this is what CoreOS. This is partly the motivation what CoreOS guys are trying to do with Docker. They're trying to define like how we ship containers, how we run them, and how we find them. So those are basically three main ones they're trying to define in the specification. It's actually quite a nice document. It's still like being drafted. There's lots of input being pushed in by from various sides, like from Mesosphere guys, and like there's lots of comments going on. So it's still like kind of like being designed. But these are the three main points, and they're all like formalized into that specification. So the three main concepts which are defined by app container specification, and that's app container image, which basically defines file system layout, verification, and local storage. By local storage, I mean where is it actually stored on on the actual host, which is going to be running the container. Verification is based on the SHA-256 hash. And then another concept is app container runtime, which is basically execution environment in which your application container is running. Stuff like cgroups, namespaces, environment variables, and stuff like that. Interesting thing about container is defined in app container specification as the Docker guys somehow advocate running one process in your Docker container. And that is running basically in its own namespace. So it has its own like full stack namespace, mount namespace, host namespace, all of that stuff for one and single process. Whilst the CoreOS guys, they're not as wasteful. They're defining container as like several apps sharing namespaces. So if any of you are familiar with Kubernetes and how Kubernetes defines pod, then it might ring a bell with you. Basically, pod is this group of containers, or Docker containers at the moment, which are sharing the namespace. And this is very similar to how app containers define something. That doesn't mean that you have to run several processes in the container, but you can. And then lastly is app container discovery. App container discovery is really just about like finding images on the internet, and it is protocol agnostic, should I say? So you can pretty much store images pretty much everywhere, and the specification defines like how you can actually discover that on the internet. Cool. So CoreOS Rocket. CoreOS, like I said, Rocket is the first implementation of the app container specification. At the moment, it's just it's a collection of tools. Mostly the most important one is RTP, Rocket, which basically, what it says now, it's downloading the image and it can execute. So there are three stages of execution in Rocket. Stage 0 is downloading the image from some location on the internet. There is some verification happening. Then the image is being unpacked, and then the process basically throws into it and executes stage 1. And stage 1 is essentially is like what it does is like it's setting up. There is a concept of executor, which is setting up C groups, namespaces, basically execution environment, and there's the last step of stage 1 is actually executing systemd spawn, which then executes systemd, which is truthed into the image which is part of stage 0. And then once we have a process supervisor running, which in this case is systemd, we can actually launch our application, which is then obviously supervised by systemd. One of the reasons why CoreOS guys came up with Rocket was because, like I said, there is CoreOS is an operating system which is using systemd as their init system, and it has some problems tracking or supervising Docker containers. When you start a Docker container, you basically do Docker run, and then you specify the image or tags or what have you, and command and all that stuff. What is actually happening is you're basically sending an HTTP request to the Docker daemon, and the Docker daemon is the process which is launching the actual Docker container. So at that stage, the Docker daemon is kind of like a supervisor, or not kind of like it, but it should be a supervisor of your Docker container. So at that stage, if you're running something like systemd, and if you write like your unit files in a way that you say, oh cool, this is the process, Docker run, blah blah, then systemd is not tracking the container after the execution happens, but it's tracking the PID of your client. So at that stage, once you do a Docker run, you hand over the responsibility for running the container to the Docker daemon. The systemd just loses complete control, and it can't really supervise the container. So that was one of the reasons, one of many reasons, but quite important one, why the Docker guys, CoreOS guys, came up with something like this, which would be more closer to what they do CoreOS. Cool. So the last thing I want to talk about is, before we jump into the demo brush, is the app container image discovery. So there's lots of interesting things. I would totally recommend you to read that spec. It's a bit early stages. There's lots of really interesting ideas like having some kind of like identity service running as a method of service and stuff like this. One of the interesting things is uploading image discovery, which was inspired by GoGet. Go is a tool for getting and compiling Go packages. So the way it works, you can specify the image you want to run. Rocket image you want to run by saying something like rocket run organization and package name. So there are two ways. There is a simple discovery and a method discovery. Simple discovery basically means that you can specify the full URL to your image, and then Rocket will get the actual Rocket image, and then we'll try to retrieve a signature. So you can basically sign an image. So if that fails, what kicks in is method discovery, and the way it works is Rocket basically Organization in the go get command is basically a DNS name of the organization. So it can be like example home. And so what Rocket Launcher is, what Rocket is doing, it's parsing the DNS name, and then it's querying a service which is running on the DNS name, and then you can serve basically static HTML with some meta characters, and then Rocket is basically parsing the meta characters, and then you can pass the full URL into your image, which can be stored pretty much anywhere. So if you don't like Docker Hub, yay, this is it. Which I don't really, I'm not a huge fan of Docker Hub, so I'm not sure how much time we have to for the demo. All right, 5 minutes. Yeah?
How long you need, it's fine.
Okay, cool.
You're only keeping people from pizza.
It's 7 arrived, so yeah. Cool. Right. We should not be. Yeah.
That's intentional. Squeeze it.
So I'll be like switching. Cool. So I wrote the servers here in Devops. As you can see, the biggest part of the code is the Rocket image. So what it does is basically, so this does, so it's a simple, very simple HTTP service. What it does is it compiles a Go template and then populates the template with some tags like meta tags, which I told you about in the discovery. So let's see if this is actually going to work. So I'm just gonna, yeah, can you guys see it? I don't know. You get it?
Yeah.
Cool. So here we are. I don't want to be, okay, well actually, cool. Cool. So I'll show you how to create a. So I have shamelessly installed this from Kelsey, the Hightower, but I thought like it might be worth to show you. This is a very simple HTTP application written by Kelsey. Basically, what it does is it registers a handler on a server root, and it basically just says hello. Got some version number. Let's just do this. Actually, let's do this. So I'm just going to compile it. At the moment, it's a bit tricky to run some applications in Rocket. Like I said, it's an early project. So I had to compile it as a statically linked binary. So let's verify that. Awesome. So this is the whole layout. This is the layout. This is the layout of the Rocket image. So basically, this is the layout of the app container image, which requires that you can specify. You have to specify a manifest and a root file system. So if you want to see what is in the manifest, whoa. This is actually just following the specification. So you specify the name of your application. This is how it can be discovered. So as you can see, there is a domain name and the name and the actual name of the application. Then we have stuff like metadata. Again, they're called labels. And if you're familiar with Kubernetes has labels, and it uses labels as a way of discovering and querying containers running in Kubernetes. And, so here we have the actual application, which is going to be executed inside the Rocket container. And these are user and group UIDs. And then there's things like annotations and words. There's lots of these things are actually not being taken at the moment into account, but there's a couple of important things which have to be there. So let's just copy hello binary into root file system. Cool. Now Rocket has an AC tool binary, which is basically an application container tool, which allows you to validate, discover, and build images. So it can actually validate the layout, and it can also validate the manifest. As you can see, it's not going to give you any feedback, but if it doesn't return an error, it means. So let's just build an image. So this is how we build an image. Actual build, and then you pass it the layouts to the file system. So what this actually does is just packs. There's a couple of things involved, but at the end of the day, it just packs everything into tar file. So it's just the same tar file. Awesome. Now let's do some interesting stuff. So we're going to push this image into S3. I've already created an S3 bucket. Oh, that was pretty fast. Cool. Let's have a look if it's actually there. Awesome. So I'm just going to start a little web service which I wrote. So, like I mentioned, you can use Actool to actually do an image discovery as well. So if you do So now you can see, oh, this is bad. It should probably finish this once, not twice. Oh, it's cool. You can report it on the Rocket GitHub. So as you can see, what it returns is, it returns the URL to where we actually push the image to. So now, in theory, we should be able to run that image. And for that, we use the Rocket binary. I'm going to run it as debug. You can see the actual stages of the Rocket run. So let's see if this is actually going to work. Cool. So we're now downloading. Awesome. So let's have a look at what was happening there. So we downloaded the image, as you can see here. Then Rocket unpacked it. It wrote, so it does a bit of compiling, And then Rocket basically unpacks, it creates an image on the file system, just like Docker. It stores its stuff in one Rocket. As you can see here, this is a content repository story. So as you can see, it generates a SHA for each of the containers to be downloaded. Once it does that, it's executing stage 1, and then it basically runs the system, the Ansible, and it launches the container inside the system D. So if you can see here, if you run PS3, you can see that system D is basically supervising the hello page running the container. Now, we should be able just to command this. Oh, wow, I'm actually surprised because I hacked on this last night and they crashed. Awesome. So yeah, so this is basically what I wanted. That's the last thing I wanted to show you guys. So comparing, just to sum it up, comparing Rocket to Docker is at least at this stage is not very appropriate. It's just at the moment Rocket is really just a protocol. So get on GitHub, hack on this. It's an interesting project, and yeah, I guess that's it. Any questions?
I must have been dreaming, but I swear the coordinator said Docker networking, so I was expecting Weave versus Helium, but never mind. Docker versus Rocket was very timely. You stressed the fact that one of the real motivations for Docker and Rocket was that you couldn't manage the process of Docker. It's interesting that Coros chose a publicity seeking post attacking the security model of Docker.
I think it's half and half. I think there are clear issues in security development. I think we all know that. At least us who work in Docker and but lots of these issues also come out. So there are two sides of it. Like Docker has security issues, we all know. But so does Rocket, we said we do. But also, there's a bigger part of the story is that the kernel doesn't really provide you at this stage with all the functionality you would need to completely secure your containers, such as what we have for the BSD. So I think there is something about it, and it could be one of those things where it's just like use it as a cheap deal. Because at where it stands, where Rocket stands at the moment, hopefully, if the promises are fulfilled, it should be more secure than Docker. But by the time that will happen, I think Docker guys might be forward as well. So it's
short answer: Docker D should be in core.
Docker D, as it stands, should be. What Docker D is trying to do is it should be a replacement of system D in terms of the quickness.
System D is great enough, way more required.
Yeah. But as like what I meant by it is like Docker D should really be, if they want to take it where they are kind of like thinking, it should really be full container supervisor at the moment. Any other questions?
Is there like anything really specific that Docker cannot like re-engineer in 2.0 release to like go through the specification of Rocket?
It is very possible because where Docker stands now is you have this like pile of code. So it's about that switching cost. It's about like how much time you want to invest just because you guys somewhere in San Francisco decided like, wow, we want this thing like the Docker can't give it to us, so we're just going to come up with this container specification. I'm not saying there's anything wrong with it, because obviously you have to protect the business and all that stuff, but at the moment where it stands, I think it would be a huge switching cost, but in the future it might happen, because it all depends. Like Alex Bowlby said it in a blog post, like what makes specification is like it's a success of its widely adopted implementation. So it might happen, for example, if Rocket is fulfills all the promises at some point, and it's going to be like widely adopted, like, for example, like for less user and usage will grow and all this stuff. Docker guys might decide, okay, why don't we just like implement stage 1, which is essentially stage 1 implements the container supervisor. Why don't we just like implement Docker D as a stage 1? So it might happen, but at the moment I believe it's just like it would be painful. And I don't think they will do it.
Blake, thank you very much for that. If you want to ask any more questions to any of the speakers, we'll be around. Pizza's ahead, so go grab some pizzas, more beers, and questions. Thank you for coming.